Hello students. Today we will discuss one or two sums of exercise 4.6. In the previous video I told you to do till sum number 14. It is good if many have done the whole exercise, but for others let me explain sum number 15 because it is given here. A matrix is given, we have to find A inverse, and then using A inverse we have to solve this system of equations. So we will go stepwise. First of all, we will find A inverse of this matrix, right? So whatever matrix is given, the first thing that we will find determinant of A, because if A is a non-singular matrix, only then A inverse exists. So when we find the determinant of A and I expand it along the first row, it will go like this: 2 into minus 4 plus 4 minus of 3, and it will be minus 6 plus 4 and plus 5, 3 minus 2. I hope now expansion of determinant along any row is clear to you. We have expanded here along the first row. So it is coming 0 plus 3 into minus 2 plus 5 into 1. So minus 6 plus 5, that is minus 1. So the determinant is coming non-zero. It means A inverse exists, right? And now therefore A inverse will be equals to 1 by determinant A into adjoint of A. So here we will find adjoint of A, and adjoint of A, if you remember, we will be finding the cofactors of each and every element here, and the cofactors of first row will be written in the first column, cofactors of second row in the second column, and cofactors of third row in the third column we will do. I'm going to do it directly. So the cofactors of first row, see, when we are writing the numbers inside the brackets, as I have expanded along the first row, so the first row cofactors are already calculated. What are the cofactors? 0, minus 2 and 1. Okay, so first will be 0, and then since this is minus 2, but when we are writing the cofactors, plus minus sign will come. So this is odd position, it will become 2, and this is 1 only. Now the cofactor of the second row, the cofactor of this will be 6 minus 5, that is 1, but it is odd position, so it will come minus 1. The cofactor of 2 will be minus 4 minus 5, that is minus 9. The cofactor of minus 4 will be 2 plus 3, 5, but it is odd position. The sign will go like this: positive, negative, positive. So here negative, so it will become minus 5, right? Now the cofactors of third row, it will be 12 minus 10, that is 2, and this is even position, so 2 will come. The cofactor of this minus sign will go, and it is minus 8 minus 15, that is minus 23, but minus sign is already there, so it will become plus 23, and the cofactor of this will be 4 plus 9, that is 13, and plus sign. So this is the adjoint. So A inverse will be equals to 1 by minus 1 into this adjoint 0 to 1, minus 1 minus 9 minus 5, and 2, 23, and 13. So when I take this minus side inside the matrix, we are getting 0, minus 2 minus 1, 1, 9, 5, and minus 2, minus 23, and minus 13. So our A inverse is calculated. This is one answer of the sum. One part is done. Now using A inverse we have to solve this. So we will write down given system of equations. It is 2x minus 3y plus 5z equals to 11. Then 3x plus 2y minus 4z equals to minus 5, and x plus y minus 2z equals to minus 3. And in the previous video we have discussed, when the system of equations is given, what we will do, the coefficients we are writing in one matrix, minus 3, 2, and 1, and this is 5 minus 4 minus 2. So this is our coefficient matrix. The variables will be gone to the column matrix, and the RHS constants also will be in the column matrix, right? So when you write this thing and you compare the matrix, coefficient matrix, it is the same matrix as it is given A. So this is nothing else but this is A only, this is X and B, and when we solve it, what do we do? So we are getting our equation here, Ax equal to B, and which implies X will be equals to A inverse B, right? And so here we will use A inverse, which is already calculated here, and if you want we can mark it as 1. So we will write down here, from 1 X will be equals to the value of A inverse we are putting, it is 0, minus 2, minus 1, 1, 9 and 5, then minus 2, minus 23 and minus 13, and B matrix is we are given is 11, minus 5 and minus 3, right? So when we are solving it, first row, first column, 0, minus 5 plus 6, then minus 22, minus 45 plus 69, and minus 11, minus 25 plus 39, right? And this is nothing else, this is 1, this is minus 67 plus it is 2, and this is minus 36 plus 39, it is 3. And what was the capital X matrix? It was the variable matrix XYZ, and from here when we compare, the value of X will be 1, value of Y will be 2, and value of Z is coming 3, right? So this sum is important. It is given only one sum in the whole chapter, but many times we get this kind of sums in our finals. When we are doing here, it seems very easy, but remember it will be mentioned in the exams, like find A inverse, and using A inverse solve it. It can go the other way also. Here we are writing the coefficient matrix, it is coming the same. Sometimes when we write the coefficient matrix of the given system of equations, it can be even the transpose of the given A also, and the same thing we will do. We can solve it by the same method, and this is how the sum will be done. If it comes generally for 4 marks or 6 marks. 4 marks very rare, but till now the sums of this type have come for 6 marks only with the option. So I hope you are finding it easy, and you people can do it now if any other sum of same type comes. Okay, now let me tell you sum number 16 also. It is given the cost of 4 kg onion, 3 kg wheat and rice given. So there are three things: onion, wheat and rice. So what we will do, as we have done in our junior classes, we will let the onion be represented by X, and then the next wheat we will represent by Y, and the rice we will represent by Z. And by taking these three variables, what we will do, obviously this XYZ will be representing the quantity, right? So here if you want, we can write down the quantity of onion, wheat and rice. And according to the given question, now what do we have? 4 kg onion and 3 kg wheat and 2 kg rice. The cost is total 60. Second, 2 kg onion and 4 kg wheat and 6 kg rice. The cost is 90. And the last is given 6 kg onion, 2 kg wheat and 3 kg rice. The cost is given 70. So once the equations are written, it is again system of equations, and you have to find the cost of each item per kg. That means what we will find here, X, Y and Z. Okay, so this X, Y and Z, what we will assume, then the let the quantity or let the rate of onion per kg we will take. So I'm making the correction here because we have to find the cost. So xyz we will take as the cost per kg for onion, wheat and rice will be represented by xyz variables, and you can do it. Okay, now when you solve this system of equations by the same method, you are getting the values of xyz. Right, I hope you can do this now. Your exercise 4.6 is complete, right? And if any doubt is there, you can ask the doubts as well from 4.6. Thank you, class.